Okay, so on page 13 today, guys, we're going to put these confidence intervals and mix them and show you how they are used in real life. Okay, everybody, so you're on page 13. Probably the most common places that you hear of the confidence intervals being used is whenever they do political polls. Okay, so the other day I was making this and I thought, I need to put some of the most recent political polls on here. So here you go. Here was one. I don't know the time, the date that this was taken, obviously before the election. So Clinton was estimated at 43%, Trump at 46%. So that, I'm sure was done by Gallup. Gallup will get 1,000 people in the country, and then they'll make their estimate from that. So that 46 and 43% are estimates. Do you think those are the true proportion? Do we know those are the real proportion of people in favor of Clinton and Trump? Okay, we don't know for sure. In fact, if you look way up here in this little bitty corner, it gives you something. I blew it up so you could see it. It says margin of error is plus or minus 4.4%. Okay, so margin of error is plus or minus 4.4%. So that means they're not sure. You could be 4 percentage points up or 4 percentage points down. In fact, let's draw some intervals for both of those two people. So let's put Clinton and Trump, and we're going to sketch out their intervals. Okay? I should have put a number line on there. Maybe for next year I'll add that in there. Let's do a little number line over here on the left. Let's start it at, I need to start it at like 38%, so I'm going to put 0.38, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Sorry. All right, so there's you a little number line. Okay, so it says based on a 4% margin of error. So I'm just going to simplify it to 4 percentage points instead of 4.4. Based on a 4% margin of error, create the confidence interval for the true proportion of voters who vote for Clinton and Trump. Okay, so first of all, what's the sample results? What's the p-hat that they got for Clinton? For Clinton is 43%, I think, right? Yeah. Okay, so Clinton's p-hat, so here I go, 38, 39, 41, 2, 3. Okay, so here I'm going to put, here's Clinton's p-hat at 0.43. All right. If the margin of error is 4 percentage points, that means my whisker will go up 4 percentage points. So what's 4 percentage up from 0.43? 0.47. Very good. So the top of her, so that margin of error means, I'm pretty confident that it's going to, and it can go up to 47 percentage points. All right, now let's do 4 percentage points down. What would that go to? 0.39. Okay, so 0.39 would be the lower bound of hers. So if this were, let's say this is a 95% confidence interval, I'm 95% confident that the true proportion of voters that are in favor of Clinton is between 39% and 47%. Okay? So I want you to do Trump's right now. Draw Trump's interval on here right now beside it. Yep. Margin of error is 4 percentage points. I don't think so. I'm pretty sure 0.46 minus 4 is 0.42. All right. So let's then fill in these numbers, okay? So if one's looking, they could say with 95% certainty that the true proportion of Trump's actual support is between what and what? Good, 42% and 50%. The true proportion of Clinton's actual support is between 39% and 47%. Okay? So here is the big question. Do we know for sure that, well, I mean, actually, we know for sure now because the election's over, but based on this poll, do you know for sure that Trump would win? You don't know. What if you are just sure that the actual proportion is in that interval somewhere? What if, look at here, what if Trump's actual support is at his lower limit? What if his is at 42% and Clinton's actual support is at the upper limit? So Trump's would be at 42% and Clinton's would be at 47%. In fact, that would be what? Clinton winning. So Clinton could actually be in the lead, and that is why it would be incorrect to say that Clinton is down 3 points in the example above, and it's incorrect to say Trump leads by 3 percentage points because there's that spread and that margin of error based on them being that close. Either one of them really could be winning. Okay? So that's the main point. That you got to get that whenever you're going to look at polls, you need to understand that. So we're going to go through another example here. Here's another graph I saw. According to the poll to the right, is there a clear winner for poll A? So look at poll A and look at the intervals down below. Is there a clear winner? Okay. Aha. The Democrat could be above, at the highest of the Democrat could be above the lowest of the Republican. So if these were the ones there, the Democrat could be winning. So if there's any overlap here, then you cannot say there is a clear winner because either one of them could be higher. All right, so is there a clear winner in poll A? No. Now, according to poll B, let's look at these two in poll B. Is there a clear winner there? Who? The Republican. Okay, so yes, and the reason is because the entire interval is above the Democrat. So even if you are at the lowest of the Republican and the highest of the Democrat, your Republican still wins. Okay? All right. Moving on. So I wanted to, so I spent a lot of time actually looking up some other information because I wanted to show you how this is also used in real life. So I looked up a couple of medical studies, and so these were actual real medical reports that I found. Warfarin, have you heard of Coumadin? Maybe your grandparents. It's a blood thinner. So if sometimes their blood is clotting and they need a blood thinner or whatever. So then Coumadin is, and then another brand of it is Warfarin. And so, of course, they're going to do some tests to see, if it's a significantly different or whatever. So I want you to take a look. Look down here at this bottom section. Okay? Do you see, look at all of those little confidence intervals. Do you see every single time, for example, let's take a look at this one right here. This first one says 2.6 plus or minus 0.4. So that means what's the sample result that they got? When they got a sample, what was their sample results? It was actually a sample mean instead of a proportion, but what was their sample results? 2.6. What was their margin of error? Yeah, remember the margin of error is that part after the plus minus. Okay, that part after the plus minus is your margin of error. So, in essence, that before could go from what number to what number? If I was to make an interval out of that, 2.2 up to what? 3. Yeah. And how did you get that? This bottom one came from 2.6 minus 0.4, and this top one came from 2.6 plus 0.4. So I added the margin of error or I lowered the margin of error. So that before interval is from 2.2, to 3. Look at this after. Let's see if there's a significant improvement. This after one is 2.7 plus or minus A margin of error of 0.5. So what would that interval be? From what to what? 3.2. So is there a significant difference in those two intervals? Is there overlap? If there's overlap, you cannot tell which one is better. Okay? So since there is overlap, you cannot tell which one is better. And in fact, if you looked at every single one of these comparisons of the before to the after, they're all going to have overlap in their interval. So can we say that there's a significant change from the before to the after? And that answer is no. So this is telling us that there is not a significant change from the before to the after. Okay? So I want to educate you so whenever you see all these different formats of things, something comes up in a study that they throw up there on the TV for a particular drug or whatever, you kind of understand what they're saying and you understand what that margin of error could change about your conclusion. All right, here is another one. I thought this was really interesting. This was actually 7 different studies. So 7 different people took their own research data and they all did a study on the same event. Okay, this one, I don't know what AEDs are or whatever. I don't know. But it was an analysis. 7 different studies were done and they were done at different locations and by different people. Okay, and I'm sure they would all be documented. But here's the thing that's interesting. Do you see how the intervals have different sizes? Some of them are really big and some of them are really small. So they had, maybe what could change how big and small these intervals are? What could change how big and small those intervals are? We recently did that. Sample size, okay? And then confidence level. Okay, if these were all the same confidence level, which one of these has the biggest sample size? Which one of these intervals that I have here, there's all these, has the biggest sample size? It is not. Hey, is this bigger sample size good or bad? It's good. Why is it good? It helps you kind of like pinpoint that better. It's a smaller standard deviation. So a bigger sample size is making a smaller interval. Yeah. See, and this one's the smallest. The reason this first one is the smallest is because look at the label of it. It's all of them combined. So heck yeah, that was a large N. Okay, but you could see amongst the other ones which ones seem to be the best. Maybe this one or this one seem to be the biggest N. Okay. All right. Okay, so now here's the other thing I wanted to tell you about this. All of these studies are happening, and so what we're interested in is where they're the same. So we would be most interested in a value that goes through the results of all of those studies. So if something is included in all of the studies, then we might think, oh, okay, well, you know what, then that's probably the true proportion value or the true value in the whole population. So we say this. When the intervals are lined up, it appears that the value that all the studies center around is that 1. They all have 1 running through it. So we kind of suspect that the population value is, pretty close to 1. Because that was the value, or somewhere really close to that goes through all of those intervals. Okay? So that's what's good about having lots of different studies, people doing different studies. In fact, when my mom was going through cancer treatment for colon cancer, I actually did a lot of research, and she had a progressive doctor who would do experimental stuff, and I had even brought a few studies to him. They would take her information, they would go do genetic testing, they would send it to the genetic lab, and they would say, oh, we feel really good about this because it has 12 studies on it. Or, we feel more confident, or we feel like it's got stronger data for it because there's been 7 studies on it and they've provided these same results or whatever. So the more studies that are on it, you're feeling better about your confidence. Okay, so there's other ways that is in real life. Moving on. Okay, so here is our final kind of discussion about these concepts. Let's just say, oh, well, hold on a second. If a claimed value is contained in the confidence interval that is created, then the obtained sample did not give evidence that the true value is significantly different than what is claimed. Holy moly, that's a big old line of what the heck was I trying to say right there? I'm sure I was thinking something really smart when I wrote that sentence, and I'm like, what was I saying? I don't know. So, hey, you know what? Let's skip that little sentence right now and look at the example that's supposed to support it. What the heck am I saying? If a claimed value is contained in the... I'm pretty tired, apparently. Okay, let's come back to it maybe like after we look at the example, and then we'll see if that sentence makes sense, okay? Here we go. All right, let's do this example. For example, suppose that it is claimed that the average amount of time that Aledo High School students take to get to school in the morning is 15 minutes. Okay? So DPS is concerned that construction along FM 1187 has significantly changed the average time that Aledo High School students take to get to school. So they take a sample of 100 randomly chosen students and see if FM 1187 construction has created significant difference in the travel time. See if it's significantly different from 15 minutes. So look here. This right here, no effect. So this line here represents it still taking 15 minutes. Okay? That line represents it still taking 15 minutes. So if the interval they got, for example, look at interval number 1. They got a p hat right there, and then they got that interval for interval number 1. Would interval number 1 give you conclusive evidence that it is now different from 15 minutes? That the average time it takes is different from 15 minutes? Okay? Let's go. Look at this interval. Hey, come on, I've lost some of you guys. Josh, let's go. Here's your interval right here. Does this give me evidence that it is not 15 minutes anymore? The answer is no. Why is no? Yeah, because it contains 15 minutes. So 15 minutes is a possibility. So let's write that down here. Interval 1 conclusion. The average time could still be 15 minutes because 15 minutes is in the interval. So they made an estimate and it still contained 15 minutes. So 15 minutes is still a possibility. Okay? All right, let's go and look at interval 2. Let's say they took a sample here, interval 2, the p hat's right in the center, and it goes from whatever that time is to this time up here. What would your conclusion be if this was the interval that they created about the average time? What would your conclusion be with that? No what? No significant change. Excellent. It could still be 15 minutes. Why? Because 15 minutes is still in the interval. Okay, so let's write that out. Actually, it's just this, right? It's just ditto. Can I just do ditto marks and not have to write that all over again? You can write it all over again if you want to, Callaway. I know. Okay. All right. Let's look at interval number 3. They got a sample. They got 100 students, and that was these should have been averages instead of, instead of proportions. Whatever. So there was their sample results, and the interval went from here to here. What kind of conclusion would you get about that time? It's what? It doesn't include 15 minutes. In fact, what do I think it is? Yes, I think that this time, the average time is less than 15 minutes. Why do I think the average time is less than 15 minutes? Because the entire interval is below 15 minutes. Okay, you know what? I should have put these as all X bars, by the way, because it's an average, so sorry. I just want to be technically correct on that. Okay, moving over here to interval 3 conclusions. So, the entire interval is below 15 minutes. So it appears as though what? As though the average time is what? Less, yep, less than 15 minutes. Good. Oh my gosh, your hand is going to hurt because there's so much writing. Oh. This is more writing than your English class. Okay, gotcha. What? Oh my goodness. Oh, I'm so sad for you. Yeah? And okay. Hey, well, guess what? I have some bad news for you. The writing only just keeps on going, and it gets more. So, sorry. You'll get more writing practice in here than in your English class, so there you go. Okay. Hey, last one, guys. Here we go. Listen up. Interval number 4. Shh, shh, shh. Take a look. Here is an interval. They got an X bar right here. They took 100 students. They averaged their time. That's a sample mean. And that interval went from this bottom result up to that top result. What kind of conclusion would you draw from that? The average height is probably more than 15 minutes. Why? Because the interval is entirely above it. So here we go. The entire interval is above. Y'all need more stamina with the writing. Is above 15 minutes. It appears as though. It appears as though the average time. Hey, let me tell you something though. I did shorten this because I should have said the average time it takes for an AISD student to get to school. Okay? So I did give you that. The average time it takes for an AISD student to get to school is what? 15 minutes. More than 15 minutes. Good. Okay. All right. Final example. Took me a while. I mean, I tried to get lots of different type of problems here. This is, say, like a marketing one or something where they're trying to take a look. Here's an infographic to the right. Shh, 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 guys. Say it has a margin of error of 5 percentage points. Okay, listen up. Shh, 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 shh. Is there a clear favorite ice cream topping among Americans? Here's your results over here. 25% chocolate syrup, 18% nuts, so on and so forth. Do we have a clear winner? How do we tell? Good, 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 good. Our margin of error is 5 percentage points, so technically we should kind of make the little intervals up and down. Which ones am I probably, I'm wondering about the biggest ones, right? Because that would be the ones that would be the most. Let me see if there's a clear one that is completely contained above the rest. So chocolate syrup interval would be what? 20% to 30%. But all of them, people that put all of them as a choice goes from what to what? 0.29 to what? 0.39. So is there a clear favorite amongst people? No. Because if you include all of them as a choice, then it could be all of them or it could be chocolate syrup. Because it could be the top of the chocolate syrup and the bottom. Oh, look at how close those are. Top of the chocolate syrup and the bottom of all of them. And so is there a clear winner? Good. No clear favorite. You can put no winner. Well, I don't know. Yeah, okay, no winner. Whatever. Oh my gosh. It's so much harder when we write no clear. Wow. Oh my, I'm so sorry that I'm just making y'all write so much. Wow. Okay. So that's the summary of these confidence intervals in real life, comparing them, and using your margin of error to do so. We will do the classwork on this packet tomorrow. Yeah.